This is David Plonsky, math teacher here, and I'm going to discuss a new method of solving quadratic equations that was developed by Po-Shen Loh, who is a professor of mathematics at Carnegie Mellon. And on the screen is his website that I will leave a link to, and that discusses his technique, and it has some awesome videos about him explaining it. So basically, quadratic equations have been solved for literally thousands of years. Okay, the Babylonians around like 500 AD developed methods to solve quadratic equations. Then the quadratic formula was developed and people learned how to factor and things like that. And you were taught in school pretty much that to solve a quadratic equation, you first want to try to factor it. And if it doesn't factor, then you could use the quadratic formula to then solve it. Or you could use complete the square. Okay, well, Professor Loh's method is genius and very simple and is even much easier to use than the quadratic formula. So we will go through some examples and show you how it works. All right, so we're going to look at this problem, which is x squared plus 4x minus 3 equals 0. And to the right, I have graphed it using Desmos. Okay, and notice the axis of symmetry, which we could calculate by doing opposite of b over 2a, which would be negative 4 over 2 times 1, which works out to be negative 2. So the axis of symmetry will be x equals negative 2. All right, so this line right here, and notice the vertex will be on the axis of symmetry, is right in the middle of where the two zeros are, or the two roots. Okay, so we have a distance z to the right and a distance z to the left of x equals negative 2. All right, we know that to find the roots, okay, we have a root of negative 2 plus z and a root of negative 2 minus z. And if you multiply those together, you will equal the c value, which is negative 3 in this case. So now we're going to do some basic algebra. And notice, this and this is really the difference of two perfect squares. So you could do negative 2 squared minus z squared equals negative 3 squared. And then doing some basic algebra, negative 2 squared is 4. Minus z squared equals negative 3. All right, we're going to add 3 to both sides and then add z squared to both sides to move things around. And we get 4 plus 3 equals z squared, or 7 equals z squared. Therefore, z will be plus or minus the square root of 7. Therefore, the roots will be located at negative 2 plus square root of 7 and negative 2 minus square root of 7. Okay, so this is really Loh's technique here, is you basically want to find this z value, and you start with the axis of symmetry. All right, we can verify that that is the correct solution by solving by completing the square. So here's a little advice. When b is an even number and a is 1, it's really easier to use complete square to solve, to get the answer. Okay, so we're going to do b over 2, which would be 4 over 2 is 2, and then we squared is 4. And then we're going to add 4 to both sides, here and here. And then this is our perfect square trinomial. This becomes x plus 2 quantity squared equals 7. Then we're going to take square root of both sides. X plus 2 equals plus or minus the square root of 7. When you take the square root of both sides, you have to do plus or minus. And then we're going to subtract 2, and we're going to get x equals negative 2 plus or minus square root of 7, which is the answer that we got above using Loh's technique. All right, let's look at another example here. All right, we have x squared minus 7x minus 5 equals 0. Okay, so we're going to find the axis of symmetry, which is opposite of b over 2a. Okay, in this case, opposite of b would be positive 7 over 2. Okay, So therefore, we're going to have roots at the axis of symmetry plus z and the axis of symmetry minus z. And when we multiply those together, that will equal c, which in this case is -5. Okay, so now we're going to do 7 over 2 squared minus z squared equals -5. All right, applying the rule of difference of two squares. So that'll be 49 over 4 minus z squared equals -5. Okay, we're going to add 5 to both sides and add z squared. So that will give us this equation. All right, doing a little math in my head. 5 is equal to 20 over 4. I'll write it out. And 49 plus 20, okay, will be 69 over 4 equals z squared. Okay, we're going to take the square root of both sides. Okay, square root of 4 is 2. And when you take square root of both sides, you have to do plus or minus. All right, so now we have figured out that z is plus or minus square root of 69 over 2. And above, our axis of symmetry was 7 over 2. So therefore, our roots will be 7 over 2 plus square root of 69 over 2 and 7 over 2 minus square root of 69 over 2. All right, so I chose an example here that gave us some fractions, but the math is very easy to do, okay? Like, even though you have fractions here, to square a fraction is pretty easy. All right, and then when you take a square root, the denominator is nicely a whole number. So those are our solutions. All right, now we could verify that those solutions are correct by, I would use the quadratic formula here. So let's try to use the quadratic formula. Okay, which would be opposite of b which would be 7 plus or minus the square root of b squared so we're going to do negative 7 squared. All right, I teach my kids, don't write out negative 7 squared. That's a mental step. So negative 7 squared is 49. Minus 4 times a, which is 1. Don't write times 1. That's silly. All right, so I don't need to write times 1. And then times c, which is negative 5. All over 2a. And a is 1. So that would be 2. All right, then you want to simplify what is inside the square root. So the minus 4ac part, so you got to be careful about signs. A negative and a negative is a plus. Okay, so it's going to be 49 plus, and 4 times 5 is 20. All over 2. And inside the square root now, you want to 49 plus 20, 69. Okay, and this whole thing's over 2, so I'm just going to separate this into like 2 separate fractions here. And notice we get the same answer that we got using Loh's technique. Okay, so Loh's technique, to me, is a lot simpler than even the quadratic formula. All right, let's look at another example here. Okay, what if we get something like this? Okay, all right, so we're going to find the axis of symmetry, which would be opposite of b over 2a. A is 1, so I'm not going to write times 1. All right, so we have negative 2 over 2, which works out to be negative 1. Okay, therefore, our roots will be negative 1 plus z and negative 1 minus z. And when you multiply those together, you're going to get 6. Okay, applying the rule of the difference of two squares, we're going to do negative 1 squared. Okay, which I'm not going to write out negative 1 squared. All right, I'm going to do that mentally, which is 1 minus z squared equals 6. Okay, we're going to subtract 6 and add z squared to get z squared by itself. And 1 minus 6 is negative 5. I apologize, my handwriting's a bit messy here. It's hard to write. Now we're going to take square root of both sides. All right, so now we have a negative inside the square root, which will mean our answers will be complex or imaginary. All right, we took the square root of both sides, so don't forget plus or minus. So z is going to be plus or minus square root of negative 5, which, if we factor out the square root of negative 1 is I, okay, we're going to write that as I times square root of 5. Equals z. Okay, therefore, our solutions are going to be negative 1 plus I square root of 5 and negative 1 minus I square root of 5. Okay, once again, we could double check that by either using a quadratic formula or complete square. Since b is even, we're going to do complete square. All right, it's easier. All right, so b over 2 will be 1. I always teach my kids to circle that, because that's what you're going to use when you're going to write the next step. Actually, let me go back 1 second here. We're going to do a little algebra here. And move 6 to the other side. All right? I got ahead of myself. All right, so we subtract 6. All right, now we're going to complete the square. So we're going to do half of b, which is 1, and then I always circle that, and then you're going to square it is 1. So that's what we're going to add to both sides. All right, everything on the left, that's our perfect square trinomial. So that becomes x, and this number right here, that's why I have my kids circle it, goes right here. So that always goes right there. So it's x plus 1 squared equals, and negative 6 plus 1, that would be negative 5. All right, now we're going to take the square to both sides. So on the left side, that removes the squared. On the right side, you got to do plus or minus. And we're going to get square root of negative 5. Okay, now we're going to convert the negative square root and incorporate I. So factor out the negative 1, that will give us an I. So it's I square root of 5. And then we're going to subtract 1. And lo and behold, we have the exact same answer that we got using Loh's technique. All right, which would be negative 1 plus or minus I square root of 5. All right, so this method is very powerful and very easy to use. Okay, let's look at another example. What if A is more than 1? All right, so I chose this problem, and this is going to have a lot of fractions, all right? So when A is more than 1, your first step is you can make it 1 just by dividing every single term by what A is. And then we're going to do the exact same technique that we have done before. All right, let's write out what we have here. Let's see if I could use the equation editor to type this out faster than writing it. Okay, this would be negative, it'll be 7 over 5. And then this would be minus 11 over 5. And 0 divided by 5 is still 0. Okay, so now we have that. Okay, now we're going to find the axis of symmetry. We can find the axis of symmetry using the original equation or this, okay? It really doesn't matter, all right? I'm going to use the original equation. So opposite of B will be plus 7 over 2 times A. So it'll be 2 times 5. All right, so our axis of symmetry will be at x equals 7/10. Okay, so using Loh's technique, we're going to have 7/10 plus z and 7/10 minus z. Okay, all right, so we need to use this equation here. And that multiplies to be what c is, which in this case would be negative 11 over 5. All right, so 7/10 squared. Okay, that's going to give us 49 over 100. Minus z squared. All right, so we're applying the rule of difference of two squares. So this quantity squared minus this quantity squared. So we have 49 over 100 minus z squared equals negative 11 over 5. All right, doing a little algebra here. We're going to move the negative 11 over 5 to the left side by adding it. And we're going to add z squared to remove it from the left side. Okay? All right, to get to 100, we're going to need to multiply by 20 here. To make a common denominator. So I'm doing this all by hand, no calculators. All right, 11 times 2 is 22, and then add a 0. So that's going to be 220. And 5 times 20 is 100. That's why we use a common denominator. And that's z squared. All right, and 49 plus 220 will give us 269 over 100 equals z squared. Okay, now we're going to take the square root of both sides. So we got plus or minus, and we're going to take square root of 269, which I don't think simplifies. And square root of 100 is 10. That does simplify. Equals z. So therefore, our roots, let's go back up. Our axis of symmetry is 7/10. So we have 7/10 plus square root of 269 over 10. And 7/10 minus square root of 269 over 10. Okay, those are our solutions. All right? We're going to do the quadratic formula to verify that those are our solutions. So we're going to take this original equation here. All right, and we're going to apply the quadratic formula. Let's use green. All right, so we're going to do opposite of b, which would be 7, plus or minus b squared. So negative 7 squared is 49. Like I said, I don't have my kids write out negative 7 squared. That's a mental step. Negative 7 squared is 49. Minus 4 times a, which is 5, times c, which is negative 11, all over 2a. So it's 2 times 5 is 10. So don't write out 2 times 5, just write 10. Okay? Now we're going to simplify what is inside the square root. Always start off with the minus 4ac part. So leave the b squared there as 49. All right, the first thing is concentrate on your signs. Negative negative is plus. Okay, and 4 times 5 is 20 times 11. That's going to give us the 220. Okay, the whole thing's over 10. All right, so inside the square root, we have 49 plus 220 is 269. Looking good. All over 10. All right, and we're just going to separate this into 2 separate fractions. So we have 7 over 10 plus or minus the square root of 269 all over 10. All right, so you can see we got the exact same answer, and I believe Loh's technique is a lot easier and shorter than using the quadratic formula. Okay? Okay, let's look at another example here. We have 2x squared minus 3x plus 9 equals 0. Okay? We're going to first find the axis of symmetry, so that's opposite of b, which would be 3 over 2a, so 2 times 2 is 4. So our axis of symmetry is 3 over 4. Okay, then we're going to, since a is more than 1, we're going to divide everything by 2. And then we're going to end up with x squared minus 3 over 2x plus 9 over 2 equals 0. Now we're going to use Loh's technique. So we're going to start with the axis of symmetry, which is 3 over 4 plus z, and 3 over 4 minus z. We're going to multiply them together to get c, which is 9 over 2. Applying the rule of difference of 2 squares, so we're going to do 3 over 4 squared, which would be 9 over 16, minus z squared equals 9 over 2. Then we're going to do some algebra, subtract the 9 over 2 and add z squared. All right, make a common denominator, which would be 16. So 9 over 2 becomes 72 over 16. So we have 9 over 16 minus 72 over 16, which will be negative 63 over 16 equals z squared. Then we're going to take the square root of both sides. So we have plus or minus square root of negative 63 over 4. We're going to pull out the negative as an I. So we have plus or minus I square root of 63 over 4 equals z. Therefore, our solutions are going to be, our axis of symmetry is 3 over 4 plus or minus I square root of 63 over 4. All right, we're going to use the quadratic formula over here to verify that that is correct. All right, so taking our original equation, opposite of b, which is 3, plus or minus b squared, so negative 3 squared is 9, minus 4 times a, which is 2, times c is 9. All right, we want to multiply out the minus 4ac part. So there's only one negative, so that's still minus. 4 times 2 is 8, times 9 is 72. So we have 9 minus 72 inside the square root, which 9 minus 72 is negative 63. All right, and now we're going to clean this up by pulling out the negative and making it two separate fractions. All right, so we get 3 over 4 plus or minus I squared is 63 over 4, which is exactly what we got over there. So you can see using Loh's technique is very simple to use. All right, I hope you found this video useful. Share it with your friends and try to learn Loh's technique. All right, be the cool kid in class that knows something new. All right, have a good day, everybody. Thank you.